we're returning to fractions here, but it's not just adding and subtracting, multiplying and dividing with numbers. Algebraic fractions is exactly the same as normal fractions. Okay, you can add, subtract, multiply, divide, make equivalent fractions. It's just that there is algebra involved as well. It's not just numbers. So what we're going to do in this lesson is we're going to talk through those basics of addition, subtraction, multiplication, division, equivalency, and then we're going to apply those into some of the more usual questions that you would get in an exam. So if we think firstly about the addition and subtraction. So we have exactly the same rule here as we do for numerical fractions. The denominator must be the same. So we must have a common denominator. So for example, if we had x plus, let's just make me a little bit more space there, x over 2 plus 3 over a. We would have to make a common denominator. Now, when we work with numbers, we look for a multiple, the lowest common multiple, right? But we can't do that here, except for we can. Okay, when we're working with algebraic fractions, that least lowest common multiple is just going to be the 2 multiplied together. So if we converted this to over 2a, okay, well, if we multiply the bottom here by a, we have to multiply the top. So we would have ax. And if we change this one to over 2a, multiplying by 2, we have to multiply on 2. 2 times 3 is 6. So now we can go ahead and add. So ax plus 6 over 2a. It behaves exactly the same as a numerical fraction. Okay, same thing would happen for subtraction. You would need to go ahead and get that common denominator. So for example, if we had 4x over 3 minus x squared over 2. This one's slightly more familiar because in this case, both of your denominators are numbers. You've got numerical denominators. So what would you use for 2 and 3? You would use a 6. Something over 6. So 3 times 2 gives us a 6. So we have to times 2 on the top. So 8x. We have multiplied 2 by a 3 to get the 6. So we would have 3x squared. So then we can go ahead and do that subtraction. 8x minus 3x squared all over 6. So you can see that it is the same thing that we're doing. It's just that we're playing with letters as well. Same story when it comes to multiplication and division. So when it comes to multiply, what do? We multiply across the top, we multiply across the bottom, finished. So top and bottom. So if we took our 2 starting fractions, the same ones up there, x over 2 times 3 over a, we would just multiply across the top. X times 3 is 3x. Multiply across the bottom. 2 times a is 2a. Lovely and straightforward. We can also cross cancel, even though there's letters involved. But in this case, there was no cross cancellation to play with. Division, remember we're going to flip and times. So we're going to take, for example, 4x over 3 divided by x squared over 2, that same one. Now we're going to change that to 4x over 3 times, and we flip. And now you can see we have some cross-cancelling that we can do. They've gone and changed my colors again. Okay, so 2 and 3, nothing in common. 4x and x squared, we have an x in common. So we can take the x out here. That would leave us with 4. And if we take 1x out of x squared, we're left with x. Then we can go ahead and we can do that multiplication. Across the top, 4 times 2 is 8. Across the bottom, 3 times x is 3x. So 8 over 3x is the answer to that division. So what we've talked about here actually touches on that equivalent fractions as well, because when we were doing the addition and subtraction, we were making equivalent fractions. X over 2 is the same as ax over 2a. Those are equivalent fractions. Okay, 4x over 3 is the same as 8x over 6. X squared over 2 is the same as 3x squared over 6. So it's the same sort of thing. Where you would multiply top and bottom by a number, you can also multiply top and number by a letter. It's exactly the same process, because at the end of the day, you're working through the same thing. So these have been relatively straightforward. When it comes to the questions in your exam, then they get a little bit more interesting. So what I've got now is a whole series of algebraic fractions questions that we can work through, so you can get to see a little bit of an idea of what goes on and how you deal with the different things. So let us say they ask us to do 4 over 2x plus 3 plus x minus 1 over 3. So you see it's very similar to what we've just done, but now we've got this plus and this minus, not just one letter, top and bottom, or a letter and a number. We've actually got 2 terms on the denominator of the first one and the numerator of the second one. But we've said that these fractions approaches apply no matter what. So we first have to, the instruction here is to put into a single fraction in its simplest terms. So we're not doing an equation, okay? We're just working now to simplify. So we can't cancel anything, we can't multiply through to cancel things. In this case, when we're doing algebraic simplification, we need to just work with our fractions. So we need to make them, let's actually take that out to remove any confusion. We need to make these into common denominators before we can add them and combine them into one fraction. So what is the common denominator of 2x plus 3 and a 3? Well, multiply together. So 3 times 2x plus 3 plus something over 3 times 2x plus 3. Same rule. If you multiply the bottom, you must multiply the top. So here we multiply the bottom by 3, so we must multiply the top by 3. Here we multiplied by 2x plus 3, so we have to multiply the top. And you can see now that these would actually cancel and we'd go back to that original fraction. Thing to always remember when you're doing this is use brackets. Particularly when you've got 2 terms going on. Look here. Here we've actually got a 2 bracket expansion. Okay, if we didn't have the brackets, we wouldn't get all those multiplications that we need to take care of. So whenever you're working with fractions like this, make sure you're using brackets. Now we can go through and we can expand things and we can combine like terms and we can actually get to our addition. Something to bear in mind, always leave your bottom as is. Because at the end of the day, you want to be factorized wherever possible. So to multiply the 3 in, then take the 3 out, you're making extra work. So leave the bottom as a factorized one. So 3 times 4 gives us 12 over 3, 2x plus 3. Plus, on this side, 2x squared minus 2x plus 3x minus 3 over 3 times 2x plus 3. So we're going to combine those like terms first before we do the addition. So 2x squared plus x minus 3 over 3 times 2x plus 3. Now we've got straightforward fractions. We can go ahead with that addition. And we take another set of brackets around our second fraction. that serves to keep the sign safe, and it's a very good habit to have because, of course, if you've got a subtraction in the middle here, it's going to affect all those signs. So even though it's an addition in this case, we're going to build good habits. So over 3, 2x plus 3. Then we can open out. So we'll move up here. Now we've got space. So 12 plus 2x squared plus x minus 3 all over 3 times 2x plus 3. So sorting out the top. Remember, we always would prefer to give a quadratic ax squared plus bx plus c. So 2x squared plus x. 12 minus 3 gives us plus 9 over 3 times 2x plus 3. And in this case, the top of that fraction doesn't factorize. So our simplest form for this addition is this 2x squared plus x plus 9 all over 3 times 2x plus 3. So let's do another one. Here we are. A subtraction, so you can see how it works. 5 over x plus 3 minus 3 over x plus 4. Same story. Okay, you got to simplify this into a single fraction in its simplest form. So we don't have an equation, we can't clear fractions, we have to work with equivalent fractions. So what is our common denominator that we can work with? Algebraic fractions, we multiply them together. So we have something over x plus 3, x plus 4, minus something over x plus 3, x plus 4. We multiplied this one on the left by an x plus 4 on the bottom, so we need an x plus 4 on top. And on the right hand side, we have 3 times the new x plus 3. So then we go ahead and we open these brackets on top, leaving the brackets underneath. So 5x plus 20 over x plus 3, x plus 4, minus 3x, 3 times 3 is plus 9 over x plus 3, x plus 4. So we've removed all the brackets on top. Now when we do our subtraction, we insert more brackets. So 5x plus 20 minus, brackets for the second one, 3x plus 9. We've combined, so we have our common denominator. We open our bracket out, 5x plus 20 minus 3x minus 9. See the sign changes? So important. X plus 3, x plus 4. Then, of course, we can combine like terms on top. So 5x minus 3x gives us a 2x. 20 minus 9 gives us plus 11 over x plus 3, x plus 4. 2x plus 11, there's no common factors in there, so there's nothing to factorize on top. And this is the end of our answer for this question. So that minus is so critically important. Those brackets keep everything safe so that the signs change when you do the subtraction. So we've had an addition, we've had a subtraction. Now let's do something slightly different again. What if we just have 2 minus x plus 1 over x minus 3? Well, in this case, that first one is a whole number. It's not even a fraction. So how are we going to turn him into a fraction? But we have to think about it. What is our common denominator? And what is our 2 really sitting like? Remember, whenever you have a 2, hiding underneath it, you have a 1. Because 2 divided by 1 is 2. That's how our whole numbers sit as fractions. So our common denominator in this case, between 1 and x minus 3, is just 1 times x minus 3, which is x minus 3. So we would have something over x minus 3 minus x plus 1 over x minus 3. If you multiply the bottom, you multiply the top. So 2x minus 3 minus x plus 1 over x minus 3. See we brackets when we put it in there? Okay, same as usual. We can open that bracket. 2x minus 6 over x minus 3 minus x plus 1 over x minus 3. Now we can combine both of our fractions, inserting brackets. 2x minus 6 minus x plus 1 over x minus 3. Now we can remove the bracket again. 2x minus 6 minus x minus 1 over x minus 3. Combining like terms, 2x minus x gives us x, minus 6 minus 1 minus 7 over x minus 3. So all of this gobbledygook at the beginning simplifies all the way down to x minus 7 over x minus 3. And what you're seeing is that we've got this pattern of steps that's repeating over and over and over again. First one is determine your common denominator. Second one, create your equivalent fractions. Your third step is clear all the brackets on top of the fractions. Then you're going to add or subtract. You're going to combine the two fractions, putting brackets in. So combine the fractions. Inserting brackets around the second numerator. Remember, the numerator is the top of the fraction. Okay? Then you can open the brackets. Carefully, because you're going to watch your signs. And then you're going to collect like terms. And after that, it gets a couple more steps that we're going to look at now. So you might be able to factorize where necessary. And you might be able to cancel where necessary. Okay, so these last two steps, something slightly different, and we haven't seen these in an example yet. So the next couple of examples are going to show you this piece. So if we have, for example, x squared plus 2x minus 3 over x squared minus 1. So now we're starting with one fraction, but they tell us that this fraction is not in its simplest form. So we need to get this into its simplest form. Now remember those last two instructions. They were factorize and cancel. So wherever possible, we're going to factorize. And we can actually factorize top and bottom of this fraction. So factors of 3 that subtract to give 2, 3, and 1. So on the top, we have an x and an x, plain x's. We have a 3 and a 1. We want to make a plus 2, so we need a plus 3 and a minus 1. On the bottom, we have a special pattern. On the bottom, we have x squared minus 1. X squared is a square, 1 is a square. This is the difference between two squares. So we have x plus 1, x minus 1. And you see how in this case, both on the top and on the bottom, our brackets are joined with a multiplication. And when you have a multiplication, you can simplify. So we have x plus 3, x plus 1, x minus 1, x minus 1. X minus 1 is on the top and the bottom. So if we're multiplying by the same thing on the top and the bottom, we can take it out. And therefore, when we simplify this, it actually breaks all the way down to x plus 3 over x plus 1. Far simpler than the original with the two quadratics. So let's try another one. X squared minus 7x plus 10 over 3x squared minus 15x. So these questions are wonderfully beautiful for testing your quadratic factorization as well. So make sure you are clued up on that. So x squared minus 7x plus 10. Factors of 10 that add to give us 7. 1, 10, 2, 5. 2 and 5 gives us 7. So x and x, plain x's, a 5 and a 2. Like signs, both negative. So x minus 5 and x minus 2. On the bottom, we have got two terms, but they both got a 3 in, they both got an x in, so we can pull that out as well. So we have 3x, and we have an x minus 5. And we have that magic situation again. We have an x minus 5 multiplied on top, and we have an x minus 5 multiplied on the bottom. So we can cancel those two, giving us x minus 2 on top and 3x on the bottom. Now the question has come through of why can't we, on this one, just cancel the x's? There's x on top and x on bottom. And again in here, we have x on top and x on bottom. But the thing is, you can only cancel when you got multiplication. And these signs here are addition, and this sign here is a subtraction, so you can't cancel. Cancellation is only when you have multiplication. So in these cases, we had a multiplication, a multiplication, a multiplication, and a multiplication, so we could cancel. But if there is no multiplication sticking things together, then you can't cancel. So when you have two things that are joined with a plus or a minus, then you can't cancel those ones. So going back to recap some more addition and subtraction questions. What if we had x plus 2 over 3x minus 4 over x minus 1? So we're back to that same series of steps. The first thing we need to do is, what's our common denominator? Both of these are algebraic. We're going to multiply them together. So we have something over 3x, x minus 1, minus something over 3x, x minus 1. So on the left-hand side, we've multiplied by x minus 1. So on the top, we must also multiply by x minus 1, and we must protect everybody in brackets. On the right-hand side, we've multiplied by 3x. So we multiply by 3x on the top. Our next step is to remove all the brackets in the numerators, leaving the denominators as they are. So on the top on the left, we have x times x is x squared. X times 2 plus 2x minus x minus 2 over 3x, x minus 1. Minus, here we have 4 times 3 is 12x over 3x, x minus 1. The next thing we do is we combine like terms. Got to simplify that top before we do anything more. So x squared plus x minus 2 over 3x, x minus 1. minus, there's nothing to simplify, 12x over 3x, x minus 1. Now we're ready to combine. We're going to insert that bracket to keep that second numerator safe. So x squared plus x minus 2 minus 12x. And even though it's only one term on top of that second fraction, we do that bracket to keep that habit. We build good habits, then we don't have to worry about it in our exam. 3x, x minus 1. So then we open the bracket. X squared plus x minus 2 minus 12x all over 3x, x minus 1. Combine like terms, x squared minus 11x minus 2 over 3x, x minus 1. And we can see straight away there are no factors of 2 that are going to subtract to give us 11. So the quadratic on top cannot be factorized. And this is then the simplest form for one single fraction based on that fraction we started with. So it really is a case of working through all and everything so that you can get through to your final answer.